Hello, very good evening. Hope you are all good. So, today we will try to look into how to perform task number one in VLSI testing and testability. So, this task aim for coming up with fault injection, that's logical fault injection, and their corresponding simulation. What are we going to do in this particular task? Basically, you could see you can construct a gate level circuit. The gate level circuit could be usage of with the usage of primitives. Basically, you see that it is being made up of the normal gates, that is basic gates, and the universal gates. Using this, you try to come up with a combo logic which is purely made up of basic gates and the universal gate. So you could write a complete Verla code for it. So what are we going to do with that combo logic? First of all, make sure, say, let's assume that this is going to be your circuit. So for this circuit, you will be having input A, B, C, D. When I say I am going to detect a fault, let me keep this output as Y. When I say that I am going to detect a fault, what does that mean? The fault is a manifest of a manufacturing defect that would have happened during manufacturing. If you consider a complete RTL, this RTL would have gone through multiple verification, that is logic level verification and functional verification, through the complete process before going for a manufacturing. Even then, when it is sent for manufacturing, there is every possibility that there could exist a manufacturing defect. Possibly there could be a short between the wires, or it could be an open in the wire, or it could be a rupture of the MOS device. So whatever may be the reason, it could end up with, or it manifests itself as a particular line expected to give me 1 but it give me 0, which you call it as a logical fault. I model this fault as stuck at 0. In case if you are expecting the value of 0 and you are getting the value of 1, I call this as stuck at 1. So basically all sort of manufacturing defect could land up with these two type of fault. What you call it as stuck at 0 and stuck at 1. Using these two, stuck at 0 and stuck at 1, we are supposed to detect that fault and say which particular test vector could detect this fault. So let's assume that this is your circuit which has been given. Basically this circuit consists of around 6 gates and 4 inputs. So there are 6 gates, 4 inputs and 1 output. So normally while you want to test this circuit, what is expected is you are expected to give 2 raised to the power of 4. That's this many possible combination of inputs, and you are supposed to get the output, corresponding output for each and every test inputs. These test inputs are called as test vectors. So probably the test vector starts from 4 zeros, then 0 0 1. It can go up to 4 1. For every input which you have mentioned here, you will be having an output Y. So for this Y, say possibly you may get the value of 0 or you may get the value of 1, like this you may get the value for 1. Remember, this value is fault free circuit output, which means for all possible combination of my input, I am getting a corresponding value at my output, which is the expected right value, which means that's the true value of that particular circuit. Now the question is, in case there exists a manufacturing defect and probably any of this particular line would be stuck at 0 or stuck at 1 permanently, how are you going to model in this particular circuit? Irrespective of the nodes or the branch where it could happen, that's free left to our choice, you can inject a fault that is stuck at 0 or stuck at 1 by using couple of gates. the point is, I artificially inject a fault in a true circuit. Thereby, I am trying to resemble the manufacturing defect that would have happened during manufacturing. Say for example, I am planning to inject somewhere here a 0, which means this particular line is being stuck at 0 permanently. How could I logically do that? The simple way to do this is, you include one AND gate, make sure this particular line is being connected with the input and the other line is being permanently connected to one tick binary 0. So what does this mean? The output of this particular AND gate will always manifest itself to give me 0 at this point, which means at any point of time this particular node will be stuck at 0. So how do I include? If at all, if I plan to insert a fault at this particular node, you just include one AND gate, bring this as your input, and the other input you make this as one tick binary 0. The output you try to bring and connect that to an OR gate. So this is one of the simplest way in order to inject a fault. Similarly, in case let's assume that I would like to insert a fault of stuck at 1 over here. How could I do this? Again, the simple way is, take one OR gate, make sure one of your line had been stuck to one tick binary 1. The other one is your input. The output is going to be this output terminal. So how do I inject a stuck at 1 over there? At this point, you include an OR gate, take this output, connect it to over here. The other end of your input for an OR gate is one tick binary 1. The output of this OR gate has been connected over here. Now this is very simple way of including a stuck at 1 or injecting a stuck at 1 in this circuit. But the point here is, make sure at any point of time there should be a single fault that could exist in our network. Don't try to simulate the circuit using two faults at a time, that we classify them as multiple fault. The procedures, the methodologies, whatever we are going to see right now is confined with single stuck at fault. Okay, fine. So we have a circuit that's purely a combination logic. For this combination logic, we know what are our inputs, what is our output. I am trying to give all possible input combination and trying to find out what is their right output. Now let me take case 1. Case 1 is, let me assume this particular node is something like E. Node E stuck at 0. When I say node E stuck at 0, I am expected to again go with all this set of test vector and generate the output and say here node E stuck at 0. For this you list out what are the faults. What are the output which you get out of it. Say this is 0 and this is 0, let me assume this is 1, something like this. Now what you could note here is, at this point, at this case, right, you could see a difference between a true output and a faulty output. One important condition to detect a fault is there should be difference between a true output and a faulty output. If both true and a faulty output happen to give the same result, you may not be able to capture that fault. So the faulty output XOR with true output should land up with 1. So this is the basic condition. So whenever you ensure that there exists a difference between a faulty output and a true output, get this corresponding test vector. Whatever may be the test vector which gives me the difference in the output for a faulty and fault free. This test vector, I say this test vector has captured this particular fault, that is stuck at 0 at node E. The same thing need to be carried out in case if I go for say, let me keep this point as F, node F being stuck at 1, and you list out all the output which you get for the same test vector. So again, say let's assume that for the 4 input, all to be equal to 1, the true value let it be 1. Here for the faulty case let it be 0. Then under this case, now there exists a difference between a faulty output and a fault free circuit output. The corresponding test vector is 4 ones. So this is the test vector. Then I claim that this particular test vector has captured this particular fault that is stuck at 1 at node F. That's the simple idea. So the whole idea is you take a fault free circuit, give all the possible test vectors, get the corresponding true value, then you try to inject a fault at any point. The fault could be stuck at 0 or stuck at 1. These are the two major stuck at faults. You could inject that stuck at fault by incorporating an AND gate or OR gate. Reality, it is not true. What we are trying to mimic is, we are trying to mimic the behavior of the manufacturing defect that happens in our circuit. True, that's it. So as a lab task, what I need you to do is take or construct a .v file, design.v. This design.v should have the complexity of minimum 10 gates. This 10 gates should be basic gates and universal gates. Using that primitives, you write a code. So minimum 10 gates, 5 inputs, 2 output. This should be the minimum complexity of the circuit. So you have design.v. This design.v should have this much complexity. So this is fault free. Fault free. Now you are expected to, second step, you are expected to inject the fault. Inject the fault. The fault should be 3 fault which are stuck at 0, 3 fault which are stuck at 1. This can be injected anywhere in your circuit. In your circuit. That's left to your choice. So now you will be having in total 1 plus 6 design, which is this 6 are faulty design, faulty. This is fault free circuit. So in total you have 7 circuits. So take each and every circuit. So if your number of input is 5, you are expected to give 2 raised to the power of 5 for each and every design. So this into 7. This will be the total amount of response which you need to get. So like this you can tabulate it. This test vector remains the same, but you are expected to get 6 faulty circuits. So 3 may be stuck at 0 and 3 may be stuck at 1, and you are free to include this fault anywhere in the circuit. Thereby each and every one circuit design as well as the fault insertion become unique. There won't be any repetition in the whole design. Okay. Now third step, get a test bench for this. Test bench. This test bench should list out or display something like this. For every test vector which you have given, what are the fault that have been detected, fault detected. for every test vector what are the fault detected. And the second thing, each fault has been detected by how many test vector. So it's on the both the way. One test vector can detect multiple fault, which mean, say I have a test vector something like this 1 0 1 1. This particular test vector can detect fault F1, F2, F5, something like this, the single fault. At the same time, you can even have a single fault F1 would be detected by multiple test vectors. Say this would be 1 0 0 1, this would be 0 0 1 1, something like this. These test vectors detect the single fault. So a single test vector can detect multiple fault. One single fault can be detected by multiple test vector. So it could be on both the way. So you can. So it could be from our one side. Okay. Right. So this is what expected in your test bench. While you write a test bench, try to display them all with appropriate test vectors which has detected what are the number of fault. Right. That is what expected. You are expected to give the conclusion in a table, or it could be listed out. So how many test vector has detected, how many fault, and the single fault has been detected by how many test vector. I believe you could have understood this particular task, that is fault injection and simulation. This is basically a parallel simulation. Means I am trying to take one test vector, say suppose 1 0 1 1. I am trying to feed this parallelly for n number of faulty circuit. This is fault free. This is faulty 1, fault 2, fault 3. So in case if this test vector detect this fault, I will say this test vector has detected the fault F1. So this is the whole idea of the task number 1. I believe you would have understood this. Straight away I will show you a quick demo how this particular job is being done in our tool. For executing this, we are using Modelsim. So you can just go ahead and use the Modelsim. Now I am just in my login. I believe you know how to use our lab, MetaGraphics server lab. So our server is 10.10.2.131. So you can use pwd. This command is used to show you where exactly the current working directory is. Now let me list out all my files. I have all this in VLSI testing 2023. So use this command cd VLSI. So it has an auto completion facility. So you can use the tab to complete that. So I have just changed my directory to VLSI testing 2023. Now list out the files ls-al. So you have many attribute for this. This will list out all the files with this. Let me go with cd lab change directory to lab 1. Okay, so let me go back to this location pwd. I'm just in my server. Okay, so I think cd VLSI. Let me list out. Yeah, I have lab. Now cd lab 1. me list out what are the files in this. Yes, so you could see all these files. Now just let me open this Modelsim. So this is basically a logical simulation. You can open, or this particular task require only the Modelsim, so you can straight away go here. So we have two files. One is fault_top.v, fault_test.v. So these are the two files which we require. So one is for the test bench, and other one is for the design file. I want you to get ready with these two files. So the model file, to have this as a model, you can just open that and see what is happening there. In fact, you can come up with your own circuit and as well as your own fault injection at multiple places. So it takes a bit of time. Yeah, so I'm going to jumpstart this, create. So you can just go ahead and create. Now this is for test. I'll simply give test_1, right? So this is the project name which I have given, and it's there in this current location. Let me give OK for it. Now add existing file. The files are there as fault_top and its corresponding test bench. I'm just opening those two. Close it. Let's try to see what is there in those two files, just to have you an idea. Then later on you can construct your own file. Yeah, so let's have a quick look at it. So I have made fault-free circuit with input A, B, C, D, 4 input, and output Y1, Y2. This is a faulty. Of course, we have used the basic gates, and it's a primitive level coding. Make sure that your coding should be in primitive. You are not supposed to use, don't go for instantiating the submodules. Let it be in the gate level primitives. Now, this is the fault-free circuit code. Now we are trying to include fault 1. The code would appropriately change because you would have inserted one AND gate or OR gate to insert a fault of stuck at 1 and stuck at 0. You could see here the corresponding value would have been made as 1 stuck 0, 1 stuck 1, something like that. That particular node would have been stuck at 0, so you would have made here. So thereby you are injecting a fault. So the best way to inject a fault is, see this, using an AND gate we have injected stuck at 0. So this is for fault 1. So very similar to that, you can keep on manipulating the circuit, but make sure that only one fault at a time. So this is stuck at 0 at some other node. So like this you can have n number of fault. So for our observation, what I said is you can have 6 fault, 3 stuck at 0, 3 stuck at 1. So make sure that you have such 1 plus 6 circuit. Next, let's see what's being said in the test bench. So what we try to do is, you try to call in all the fault free as well as faulty circuits here. This is the test bench. We have called upon fault free circuit, that's the first one, and again 6 faulty circuits had been brought in, and we try to display for each number like what is the test pattern, what is the fault free response, and what is the faulty response. I want you to think about it and you come up with your own style of representing it, even as a table or whatever method we could. So this is the first test vector which has been given, where for 4 input, all the 4 inputs are starting from 0. We slightly move on. This 4-bit input had been given for all the faulty circuits as far as fault free circuit, and you are trying to compare both the results. Similarly, after 10 unit of time, you are trying to change your input test vector from 00001. Again, after 10 unit of time, you are trying to make it 0010, so it keep on like 0011. So you are trying to explore all possible input combination that could be fed in. So that's how the whole code, if you look at, so for all possible input combinations, this would be applied for the faulty circuit and fault free circuit, and the corresponding result would have been displayed. In fact, I recommend you to go ahead with your own style of writing the code. After doing this, compile all the code. Once you compile these two, you will get this tick mark. I believe you might have worked with the Modelsim. Now go for simulating, start simulation. So my fault underscore top has, the fault underscore test bench, that's the one which I am supposed to look in. Fault underscore test, give OK. That is the module name. So you can see your output in two ways, one using output waveform, the other one using the transcript window. So like we will go with so it takes a little bit of time. So what you can do is, in the object window you have all the signals. You may use shift button and say, suppose these four are my input, y1 y2 are my fault free output, y1 y2, there are two outputs here, right? And f1 f2 are for the faulty one. So let me try to assume that I am trying to save the first one fault alone, or you can add all this fault, everything you can do it. So add to waveform, selected signal, or you can completely pass those complete signal also. Then run this simulation. Okay, I am trying to run this simulation. Let me unlock this waveform window so you can zoom out. See, whenever these are my expected output, this is my undesired output, means my expected output y1 y2 for the test vector 0010 is, this is expected to be 1 1, but what I am getting is the output y1 is giving me 0, which means 0010 has detected the fault of y1. Can you see here? Because these two outputs differ. So similarly you could see for there won't be any deviation in some cases. So this particular test vector 0110, what you could notice here is, again y1 value differs. Like this you could see which are the test vector which could, here this test vector you look at here 0111, there is no difference between the true value and the faulty value. So this particular test vector is not detecting any of the fault. So like this you can come up with say this vector also 1000, it gives me the same result as the faulty one. I have considered only the faulty one circuit. Like this you may be having 6 faulty circuit in the network. So you are expected to go with all the 6 and see for this particular test vector which are the fault that has been captured. I believe you got it. Next, you can even go with this transcript window and see what are the faults that have been available. So look at here. So these are the fault. Say number of single stucket fault is 6, which means we have given 6 fault. Test patterns, what are the test pattern? And fault free response, what is the faulty response? Say suppose this is the test pattern. F1 fault is detected. How do I say it is detected? For this 40 as your input, the true output is y1, y2 is 1, 1, but the faulty output, that is y1 underscore fault f1, y2 underscore fault f1 is 0, 1, which means this 1 has been changed to 0. So there exists a faulty output which has been captured by this 4-bit input test vector. Similarly, you can give all the test patterns starting from 4 zeros to 4 ones. So that will list out what are the faults that are available in my network. So you will get the complete transcripts of total number of test vectors and you can list it out. Hope this was useful. I request you to make it in the format which we said. So come up with the circuit for framing your own circuit and applying your own faulty circuit, fault in my circuit, and then you can just go ahead for simulating that fault and capturing that fault. Okay, thank you. Meet you in the next video.